Today we're going to talk mainly for the next hour about support lines and splitters in the program. This is one of the, I would say, the hot topics, or one of the more difficult topics that some users have with the software, and we want to make sure that everyone has a chance to learn more about them, how we can avoid problems with the input of support lines and splitters. Splitters specifically, what are they used for? Why do we want to use them? And we're going to explore some of those topics. So today we're going to start out with a very simple example, and then we're going to move into a more difficult slab. So here on my screen you can see we have just a rectangular slab. Everything is nicely aligned in the orthogonal axes, both X and Y. And then if we move over to the model that we're going to use for a more detailed example, if we go into this model and navigate down to one of the specific floors here, this has some intricacies that can potentially create issues with how support lines and splitters work, and we're going to go ahead and explore this particular example in more detail. So to begin, we'll go back to this base model. Just before I begin, if there are any questions, if you can use the question option in your GoToWebinar panel, you should be able to ask a question, and I will answer all questions as I'm moving along in the training or in the webinar. If they are specific questions to any troubleshooting problems you've had or issues that you've had in the past, it may be best to send those to us directly at our support group, and we'd be happy to help with those particular questions. So we'll go ahead and take a look at this model. So what is the purpose of a support line? If we look at this slab, which is a two-way slab, it's bending in both directions about X and Y axes, and I've analyzed the slab for just the base load combinations. If I look at, for example, the slab moments, and I turn on the MXX contours, and we see we have some scale of moments. This is actually kip feet per foot. It shows kips here, but it's the way the units are shown. So the range of moment about the x-axis is between 6.17 kip feet per foot down to negative 26.91, where the negative is obviously at supports. This is positive bending in the span. If I go to the other axis, MYY, we get something similar. We get a range of 4.97 to negative 23.08. So they're roughly they're in the same ballpark in terms of what the magnitudes are for the moments. And so if we were to take this slab and we wanted to design it, we would have to have some basis for, or some approach for using these moments in order to design. One approach might be to use reinforcement or intensity contours for reinforcement. So similar to what we're seeing here for bending, we might have reinforcement contours. Now that's one approach that software providers use. ADAPT uses what we call a strip approach. So in order for us to take these moments and convert them essentially into reinforcement and meaningful output in terms of reinforcement or stresses, stress checks for example for post-tension slabs and so on, we have to have some way to discretize this structure, this slab, into finite strips, and those strips each having their own let's say tributary width along spans. So in order to do that, we've introduced the option for support lines. A support line is used in general to define a tributary region in the slab or on the slab. So if you were to take, for example, this interior frame line, and you took that and you extracted it from this model, and you used the equivalent frame method to design that frame line, you would come up with a 2D model which essentially leads you to actions along the length of the frame. You'd have shears, moments, potentially axial forces, depending on whether or not the software considers that. ADAPT PTRC, which is a 2D program, does not consider any axial deformation, so you're really left with shear and moment. It's a simplified approach which is allowed by most codes, the equivalent frame method, and the mechanism by which you would design that frame is literally just taking sections along a 2D frame and designing for the actions. So in Adapt Builder, the analytical approach is not the equivalent frame method, it's the finite element method, but we're still using the strip method, if you can imagine, overlaid on top of those results to obtain the actions that we want to design for. And I may pause here. Yeah, the question is, what time do we start? We start at 1 o'clock Pacific time. So I don't know if, I think it's 1 o'clock Pacific time, should be. So I'll continue, but we're going to define strips so that we can obtain results both in terms of stress checks and also reinforcement. Now, the question is, how do we define support lines? Well, let me go ahead and clear this contour. There's really two ways to define, I should back up, how do we define design strips? A design strip is really just a tributary. It's a tributary strip or a frame line in the structure. There's really two ways. One is to have the program generate the design strips for you, or the second option is to manually create the support lines yourself. The first option requires the user to generate support lines. The support lines allow the program to define the tributary regions, and many times you have to introduce what we call splitters, which are really just virtual boundaries. They're only used for the program to interpret when generating and formulating the tributary regions. So I'm actually going to explore the second option first. So if the user wants to define all tributary regions without the program doing this for you automatically, if we go to the strips menu, this is where we go to generate our strips. You can see there's an option called Create Tributary Region. If I select that, nothing happens because I first have to at least have a support line in place in order to generate a tributary region. So I'll go ahead and just add one support line, and we'll talk about the directions of the support lines in a moment, but for now I'm going to just add this in the X direction, and I'll just add this in this area here. So I'll go ahead. I'm going to use snap tools frequently during the training. The snap tool usage is very important to the just the functionality and the placement of the support lines. So general rule of thumb, when you're using snaps to generate and place support lines, use as few of snaps as necessary. So if I go and turn on all of my snap tools, the program is going to go crazy trying to determine exactly where to snap to. This, again, simplified example doesn't really exhibit that behavior, but again, the most common snap tools you will want to use when you're generating support lines will be snap to endpoint, which is the first snap tool, snap to perpendicular, and snap to nearest. We're going to be turning that off and on in the course of the webinar today, or this training. So I'll go ahead and go back, and we're going to go and just snap on the edge of the slab. I'll snap to this column here and here. Now if I have support lines defined in the program, I can select a support line and I can assign my own tributary to that support line. So if I go back to strips, create a tributary region, I can now draw a tributary, any customized shape. You can see it looks like the Rocky Mountains here. So this becomes my tributary for this region. If I was to add another support line after I've created that strip, that's okay. I can add a support line here to this top frame line, and I'm going to again select that support line, and then I'll go ahead and create another tributary. Now notice I have snap to nearest turned on. This becomes difficult to snap on that exact point. So I want to turn that off. I'll toggle that off, and now I'll just use essentially snap to endpoint to create this next tributary region. Excuse me. So we have two tributary regions that we've manually defined. My recommendation is if you go the route of manual definition, you do not want to intermix the two. You don't want to create some tributaries and have the program create others. It's difficult to work in that mode. So assume we create all of our tributaries here using manual input. I've only done two, but if I go now to strips, generate design sections automatically, regenerate tributaries. This is really a two-step function. So when we select regenerate tributaries, the program, whenever you have this selection regenerate selected, that's telling the program you create the tributaries. It basically overrides the user's input of manual tributary regions. If you use the option for existing tributaries, then this is telling the program to generate the design strips and the design cuts. You can see this says design sections based on the user input. So if I select use existing, I have a strip here, which you can see the cuts are kind of bound by this jagged line that I input, and I have the strips below. And they're contained within those regions. Whenever you generate tributaries, one way of visualizing them is to use what we call the Report Plans toolbar. And I'll go to User Interface, I'll open Report Plans toolbar. This is really used mainly for reporting, for generation of a strip report, but it's a great tool to visualize what the program has created in terms of the tributary regions. So I'll go here to the X direction. Notice I don't have the option for Y because I haven't input any Y direction support lines. And I'll just say OK. And this shows me the hatched view of each of the tributaries. So the program is basing this off of my input, not the user's, I'm sorry, not the program's generation of the tributaries. I'll go back now. Let me go back and view the two strips. So now I'm going to go back, and let's say I create a slab full of my own customized tributaries, and I accidentally go, and I'm sure some of you may have experienced this before. It's a frustrating experience, I'll be honest and say that, but if we go to strips, generate design sections, and I select regenerate, remember this tells the program define the strips using the algorithm that's coded in order to generate the tributaries. And now you can see it looks completely different than what we defined as our manual tributaries. What the program is doing is it's looking for specific hints or clues as to how this strip needs to be created based on the input of our support lines. So I'll use my marker here to show this. We have a support line which goes from here all the way to here. We have another support line from there to there. Notice that they're both touching the edge of the slab. So that's a key ingredient in how the tributaries are generated. It's touching the edge of the slab, which is a boundary. So the program sees a boundary here. It also sees a boundary right there. And at the top, there's a boundary. So that just tells the program stop the tributary at that edge. It's a slab edge, so it's a perimeter slab edge, more importantly. The design cut then is made over the tributary region. It's perpendicular to the support line, and the design sections are cut over that tributary panel, if you will. So the panel that the program is dictating or creating is right there, and it's basically taking the distance between, half the distance between this support line and the support line below, and it's taking this as the tributary. Now for this support line here, I'll just put an arrow so you can see where that is. We see that above, it knows that there's a support line above, so it splits this in half, but below there's no other support line. There's just a slab edge way down at the bottom. And the program looks below doesn't see any support lines, it doesn't see a virtual boundary, which is a splitter, and so it actually fills in that tributary all the way down to the bottom of the slab edge. And obviously this would be incorrect when you're integrating over the finite elements. You don't want to integrate over that long of a integration path, if you will. So this would be incorrect, and this happens sometimes if the user misinputs or doesn't snap to the slab edge or doesn't include splitters, or there's various reasons why this would occur, but here this just simply occurred because I don't have support lines there, or there, or there, or I don't have a splitter. So now if we go back, and let me just trash that drawing, and I'll go back and just discard the strips that were created. And now I'm going to add a splitter. So one of the common mistakes is adding the splitter assigned to the wrong direction. So I'll go ahead and I'll create a splitter. And this splitter is going to be labeled as an X direction splitter. But the most important thing you can remember about splitters is that the direction assignment has nothing to do really with the orientation of the splitter, how you align it in the model. An X direction splitter can be vertically aligned along the y-axis, it can be along the x, it can be diagonal. It's really used to tell the program this is a boundary. Stop the tributary region at this boundary. So I'll give you an example. We have an X direction input. Remember, we have X direction support lines. These are labeled X, so we need to assign X direction splitters that will influence the creation of tributaries relative to the X direction support line. So now I'll just put a splitter, and again I can make this really any shape. I'll even go up like that and cut across. Back to my highlighter here. Remember, we have a support line here, we have one above. It's bound on both sides, so the tributary should be cut in half. And because I have a splitter now below this support line, this is now going to be bound by that shape right there. And this is an enclosed shape all along here. That's an enclosed tributary. And that's the use of the splitter in this example. So I'll go ahead and create my my tributaries. We'll go to Strips, Generate, Regenerate. Now I have this shape for my tributary. And again, this up here. If I change that to Y direction, for example, and I go back to Strips, Generate, and I'll regenerate, the program ignores it. It's trying to create tributaries for two X direction design strips. This is X, and it sees a Y direction splitter, so it says ignore that splitter. It's not used for this strip direction, and it just simply ignores it. Now if I took this and let's say I change this strip direction to Y direction, and I'm only changing this strip direction, now it's going to be bound at the splitter because I changed this to a Y splitter, but you're going to see the program will ignore this support line because this is X, this is Y, so now the distribution will shift and it will extend up to this edge here. So I'll go to Strips, Generate. So now I have I'm actually mixing two different directional strips. If you go to the Select Set View Items, the blue eyeglasses, I'll turn on my X strip first. And X strip, you can see, is this. Goes from the top all the way down to the bottom. It's skipping that support line here because I changed it to a Y direction support line. So if I now go and flip-flop this from X to Y, you'll see that this is now the strip for Y. I changed the splitter to Y, I changed the support line to Y, and we're left with this. X and Y are not required to be aligned in the orthogonal X and Y directions. If I wanted to label all of my X direction physically my X direction support lines as Y direction strips, that's fine, but obviously it's confusing to the user if they're expecting them to correlate and match. As long as your support lines do not intersect having the same designation, it's acceptable to use them any way you wish in terms of labeling and direction. So let me go back here and turn these both on. I'll turn my splitters back on. I'll reset this back to what I had previous. So I think this was, that's Y. So if you, by the way, if you look at this, you can tell a Y direction splitter by the square at each of the nodes. An X direction splitter will have circles. So graphically you can distinguish between the two. This support line here is going to be changed back to X, and then we'll change this back to X also. So I'll go ahead and just discard this. And if we have a situation, I'm going to draw in some Y direction support lines, so I'll go to Y direction, and I'll just kind of sloppily input this. Now, if for example, for some reason you didn't remember to change the direction of this, and I change this to X direction, after the fact, if I go to generate my strips, you're going to receive an error. It's going to say one support line intersects another and they have the same designation, essentially, the same span direction. So it will highlight the intersecting strips or support lines. We look at this, we say, this is X, it should be Y, and now we go back, we generate our strips, and we don't get the error. The program generates the strips, and we get acceptable strips in this case. So be sure that when you're inputting the support lines there, they are in different directions. There's a question, so let me go ahead and answer. It says, can it be summarized the direction of the splitter is to be the same as for the support lines we are trying to limit or distribute the tributaries? Yes, that's correct, Pavel. To summarize, if you're trying to generate strips or let's say mold or kind of manipulate strips using splitters, the splitter has to be the same direction as the direction of the support line. And then the next question is, do support lines in a specific direction all need to be parallel? The answer to that is no, they don't. Support lines really just allow the user to generate data, let's say data points. In reality, it's a data line. It's a design section for zones in your slab. So I'll give you an example. Actually, the model we'll work on is a good example of that, but support lines do not have to be parallel. They don't have to be parallel. They don't have to align with the global X and Y directions. If I took this slab, I'm going to generate, I'll use X direction again here. And I could, and I'll input these very, I don't recommend inputting how I'm doing it, but just for the sake of time, you can see I'm actually inputting these on a diagonal. They are parallel, but they're not in this direction. And then let's say for this one, I go like so, and then maybe I start here and I go out. Now notice that I'm actually, this one right there, these come close to touching the same point. It's okay if support lines of the same direction share a point, but they cannot intersect. So for example, I just deleted a support line. This one I would go there, I can snap on that point, snap here, and then snap there. These share a common point, but neither of them intersect the other. So this is still acceptable input for support lines of the same direction. So you might, and I've seen this type of configuration before, where you might have a slab that is orthogonal and then it bends so many degrees, and you have to, at the point where the support lines merge, you have this kind of common point along the column line. Let me go ahead and answer another question. Yeah, what are the effects of a single line changing direction? It's a great question. And it happens, I would say this happens without the user knowing sometimes when you use the support line wizard. You'll notice I haven't even touched on the support line wizard. Personally, I don't like to use it, especially if you're new to the software. I don't recommend using it. I think you'll learn more if you manually input the support lines. So the question is, what happens when a support line turns, it has a directional change along its path? And I'll do the same. I'll go to, let's say, again, X direction. So we'll go here, here, there. Let me input just a few of these. And this one, I'm actually going to turn it and then come back like so. This is an exaggerated turn, but this happens every so often when you use the wizard, depending on where the program is scanning and where it looks and sees points, for example, at a wall intersection or a wall column intersection. And then here I'll go like so. So the person is still alive, right, in this zone, not flat line. Okay, so we have a couple of very sharp turns in a support line. If I generate my strips for this set of support lines, I'll regenerate tributaries. Remember what I said earlier, that the design cuts along the path of a support line, we have perpendicular cut design sections. Think of this as a free body diagram, or a beam, and at between columns over a beam, you cut the beam, and you can get the moment and the shear, and you design for that. That's essentially what's happening with these design cuts in the slab. These are just data points where the program pieces the moments, the shears, all of the actions along each of these design cuts, and it uses that to generate the reinforcement, to calculate, let's say, stress requirements or stress values, etc. And so if you have a sharp turn in a support line, where was my first one? There it is. You can see right here, this is an X direction support line, so all of the cuts are made in the Y direction. So we're actually looking at bending. The primary bending direction here is about the Y-axis, but because I turn this up, these cuts are actually cut in the X direction. So along an X direction support line, where we're primarily concerned with Y-axis bending, you actually have a situation where you're looking at X-axis bending. So this would be, this is not good. You don't want conditions that look like this in your support lines. And you can see those integrate all across the slab because there's no boundary to stop them. It goes from edge of slab all the way to edge of slab. And these really should be assigned to Y direction strips. So something like this, if you have that type of mistake in your input, you can always select the support line, go to this option to delete a point, or you can add a point if you needed to add one, and I can just delete this point. Here I'll go ahead and delete these 2 points, and now I get a correction in my support lines. And then we get our strips right here. So this is a post-tensioned slab, and you can see that the strips that we've created are really over the full tributary of the full tributary of each frame line. There's a side debate that you can always have whether or not it should be column strip, middle strip. In reality, most post-tension slabs, especially in the U.S., are most, I would say, most designers that we see, or designs that we see, or models, have the strips as full tributary for post-tensioning, and then obviously column middle strip for a non-post-tensioned, just a regular two-way slab. So if the user wants to create strips for a RC slab, right now I'm in adapt RC and PT mode. So if I go ahead and save that, I'll close this model. If I reopen the program, you can see I'm in design scope RC and PT, and there's no automatic option for creating middle strips when you're in this mode. So if I wanted to have created middle strips in that previous model, I would have had to draw in the middle strips also, or the middle strip support lines. If you go into RC mode, and let's say this is truly an RC slab, I'll just reopen the base model. And by default, in criteria, under the design section options, or under analysis and design options, there's this option for column strip, middle strip. And the option is somewhat constrained. Sometimes it doesn't generate the strips exactly as the user wants the strips. So it's a give and take. If you have a very simple layout and this option can be used to generate the middle strips, then great, I would recommend using it. If you have a very complex layout, it's probably best to turn this option off and just assign the middle strips yourself. That's probably easier than trying to fight and force the program to do something that it's just not built or formulated to do. So if we turn this on and I generate my strips again, we'll use the program to do that. The program now creates a middle strip automatically in between the column strips. And you can see this middle strip has been added. As the user, you can actually modify the tributaries of a column or a middle strip. So if I go back to my report plans toolbar, I'll turn on those tributary regions again. And let's say I want to manipulate the tributary that the program generated. Earlier I said I wouldn't recommend mixing. This is an example of now mixing the two. So let's say I want to stretch this tributary out and I want to move it from here down to there. And then I want to move this, let's say, down to, let me turn off, you can see my snap tools are trying to snap everywhere. Oops, that didn't help. Let's move that there. And then I'll move this one down to here. So we'll see I'm adjusting what the program has created. And if I put that there, there's going to be a tiny gap. I can create a gap in the tributary. Not that you would want to, but this little sliver has no tributary associated with it. Once I manually make a change and I go back to strips, generate strips, use existing becomes active because the program knows that I just made a change to a design tributary or a design strip. Those are used interchangeably, and I can use existing tributaries. And when I do that, I'll go ahead and exit out of that first. You can see that this strip now gets adjusted to how I manipulated that region. So moving forward, if I needed to make a change, let's say a column moved or a wall moved and you had to realign one of the support lines. So I say, oh, this column has now moved, so I'll just select that and move it from there down to there. If I say, well, now I need to readjust this support line, I go back and I regenerate. The program now overrides the change that I just made to that tributary, and I have to do that over again. So it can become tedious if you're having to go through multiple iterations of making changes. So that's why I recommend that I would stick with one method versus another. And I truly believe that if you learn splitters and how they're used, it becomes a more efficient way of generating strips in a model. Okay, so we're going to leave this model. We're going to go look now at a little bit more complicated of a model. This model, we're going to get into the details of how we want to use strips in a real life example. And so we have some intricacies with this model. We have kind of this pinched area. This is a slab. This is a 10-inch slab. The rest of this area is 8-inch. And then we have these two areas out here that are essentially sunken. They're dropped, I think, 2 inches. So if I take a section cut from here over to there, let's say, you can see this is my 10-inch slab. There's a step right there at the face of that beam, and then I get into that one-way slab with beam, kind of the arc region, and then I get back over into another 8-inch or 10-inch slab. So, and in between there's an opening there and there. If I go to a rendered view of this, it's easier to see all of the openings. So here we see we have several openings in this model. And again, we want to talk about how do we treat openings with respect to splitters. And I'll give you, first we'll start with a couple of rules of thumb on how to do that. So let's take this opening here, this series of openings for example. I'm going to draw a line which will just represent a support line. So there will be a support line here. Let's say there's a support line somewhere along here. And then I'll do another support line that kind of does that. So when the program cuts through and generates design cuts along this support line, it's going to generate design cuts through an opening. So the design cut looks like this. And what that really looks like is something physically. That cut is like this. There's a big opening there, and then it does this. So there's clearly a discontinuity in the design, the physical section cut, but the program actually translates this into a cut that is combined. So it's taking the integrated action over the shells represented by this area on one side, and it's taking the integrated actions by the shells on this side, and it's basically mashing them together into one cut. And the program takes this cut, which is called the idealized design section. It calculates the centroid. It finds the moment, the shear, the axial force, whatever other sections at this centroid. It designs for these actions. So you need 2 square inches of steel for this design cut. But part of that steel has to be distributed to one side of the opening and the other side. And number one, most users don't get to that level of distribution. I just don't think people think about it, to be honest. And they don't go to that level of trying to dissect the results. And number two, sometimes users just don't realize what's happening. So when you have a design cut which goes into an opening and exits the other side of the opening, you have to use splitters in order to generate the proper tributary. If you have a design cut, which, and this is a good example, let me go to that example here. So over here we have a design cut which would look something like this. It would extend into the opening along this support line, and along this support line it would extend into the opening, but it doesn't extend out of the opening. So this is okay. This particular opening that's kind of in between the two support lines technically does not require any splitters. Even though the design cuts extend into the opening, there's no concrete there, and that means there's no shell element there. So it cannot obtain a value where there is no shell or node, and it's basically just a void. So graphically it shows the cut extending into the opening, but in reality it's acceptable because the integration really stops there and it stops right there. Okay, now some users want to see no cuts extending into openings. So for this example we will place splitters around all openings so we can try and get a situation where we have no no opening with tributary region extended into it. Now, we're going to really dissect this slab into really three zones. We're going to do the X direction first. If we have time, we'll do the Y direction, but X should give us a good idea of what we're after. And we're going to create strips for this rectilinear slab, and then we want to create separate strips for these regions that have kind of this radius shape or have these arcs out on the edge with the beams. So we'll start off in this upper corner. I'm going to use my modeling toolbar. I can also use my strips pull down menu, but here I'll just use the modeling toolbar. We're going to create support lines. Remember to go to properties, make sure this is in the right direction that we want to assign this to. This is the X direction. Whenever you generate support lines, you want to stop them or start them at a slab edge. Sometimes it's not convenient to do that, and other times it's not realistic to do that. So whenever a support line stops or starts inside of the perimeter slab, we have to use a splitter as a boundary, and I'll show and illustrate an example of that. So we'll go ahead and we'll start at the slab edge, and here I'm using snap to endpoint. In fact, I'll pull the snaps down. Endpoint, midpoint, perpendicular. I also have snap to vertices of components turned on, which allow me to snap to corners of walls and columns and beams. So we'll go from this slab edge. I'll snap on the midpoint of the wall, and we want to define where we have a physical support here. And notice now my snap tools are kind of hurting me, so I want to go and turn off a couple of those options here, especially snap to vertices of components. When I click on support, for example, a wall, a column, that's not telling the program there's a support there. The program already knows that there's a support there because it's part of the model. The program uses that support in the overall frame analysis, and it knows that it's there. The only reason we snap on columns and walls is it defines a span length for that strip. So the span length is used to calculate the rebar lengths for minimum requirements, for example, over supports or in the midspan of a section. An example is over supports. You might extend the rebar L over 6 to either side. Well, what's L? In this case, L is the distance from this point to this point. So the program can extend that. Had I just clicked one point here and another point over here, the span length is wrong. So the extension of rebar for minimum requirements would be potentially wrong because it only sees one span, and it doesn't know that it needs to create the distance on both sides of that particular column. The span length of a support line only affects placement of minimum reinforcement. It does not affect strength. So if I snapped from point A to point B, I'm still going to get a bunch of design cuts which result in moments, negative near supports, positive in the midspan, and the program knows what to do with those moments for purposes of ultimate or strength design. But for purposes of minimum or serviceability reinforcement requirements, we want to properly define the spans along the tributaries. Okay, I'll go back. Now, remember, I'm going to ignore these areas, these curved areas out on the outside. So I'll go from this support down to here, and as I'm doing this, I'm going to explain a couple of things. The rebar follows the direction of the support line. So when the program generates reinforcement, it's going to follow this support line, so parallel to it. There's an option when we generate reinforcement to straighten it out relative to the X and Y axes, and the program actually, it will convert the amount of rebar based on the rotation angle for a given set of strips. Here you can see I messed up on that. I'll just take that point and drag it back to there. I keep going up to the menu there. We're also going to add one along this side. When we have a post-tension slab, it's recommended to follow, I would follow the direction of the tendons, the banded tendons in one direction. In the other direction, we want to follow more orthogonal layout of support lines. The reason we want to follow the banded direction is the tendons that intersect design sections along that band will have primary effect if they're perpendicular to the section. So what I mean by that is if I have a design, here's my support line, let's say, and I have a bunch of design cuts, and let's say my tendon direction is like this. This is my banded tendon. That banded tendon is intersecting these design cuts, but it's intersecting it at an angle. Let's assume it's 45 degrees. So you're really only getting a contribution of the PT relative to the angle at the design cut. That not only affects the stresses, let's say, but it also will affect the rebar. How much rebar this section has in terms of capacity generated from the PT. It doesn't have full capacity. It only has a percentage of the capacity of PT because of how it's aligned with the banded tendon. Now, as I guess an argument to that is if I have a banded tendon that looks like that, but I also have distributed tendons that look like this, those are also intersecting these design cuts. So not only will these design cuts that are kind of in the X direction here, not only would they be affected by the banded tendons, but they're also being affected now by the distributed tendons. And that goes against, I think, the kind of the traditional way you would design post-tensioning in a non-3D environment. You know, you typically say, for this direction, we're assuming the banded tendons provide 100% contribution to the frame lines in one direction, and in the other direction, we assume that the distributed tendons provide contribution. So to avoid this particular type of result, we want to ensure that the support lines follow the direction of the banded tendons. Before you start laying out support lines, it's really best to, I think, have a good idea of what the banded and distributed layout will be for a given slab. I'll go ahead and hopefully get more of this done. This is a condition where we're going to terminate the support line at the corner. It could go to here. I mean, that's a viable load path, let's say, from here up to there, but we're going to just stop it. We'll assume this being the banded tendon direction, we might anchor a tendon out here and then run it through and exit it out on the right or the left-hand side. So that follows, for example, my tendon path. And remember, here I'm just really snapping on the walls, ends of walls and columns. There's also some beams along the path. You can see there's a beam here. And I'll talk about beams in a moment, if time permits. I'll turn on my snap to nearest, and now I can snap anywhere along that slab edge. I'll just snap there, and we'll go snap middle of wall, and then I'll stop. I'm also going to just put a small support line over this wall. I try to add support lines over any wall in the direction I'm working on. If you have a situation where, let me just draw a quick example. Let's say we have a wall here, and we have a wall down here, and then I have a column, 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 and my slab is something like this. So sometimes we'll see slabs which have a support line here and a support line right there. but they don't. A user may not put a support line along a wall because it's a continuous wall. There's no deformation on top of the wall. There is as you kind of creep out towards the column lines, but for whatever reason they don't put a support line here. Now when I generate the design cuts, the cuts along here will go from here all the way out to the edge of the slab and from here to the edge of the slab. When a design cut cuts over a wall, the program does not report stress, number one. It doesn't design for reinforcement at a strength level for design cuts that extend over a wall. So in this result, I would get 0 rebar for strength purposes. I would get no stress check, and I'm integrating over a zone that goes from, let's say, positive bending, and then it creeps over to negative bending. So the net effect is very coarse in terms of the result, right? So here we would definitely want to go and add support lines over walls. This just simply refines the distribution of tributaries, and now this section cut gets taken down to something like that. This gets taken down to something like so, and then we get 2 additional design cuts. There's obviously design cuts all along this strip. So this just refines the results for this particular layout and arrangement. So there's a question. Yeah, okay, Pavel. Yeah, that's the. Pavel was asking about the cut over the wall. So whenever I have a wall, I always add support lines. It just helps refine the results in the overall scheme of the layout. Okay, now this beam I'm going to assume is a support. In reality, I probably wouldn't. I would not anchor the banded tendons at the midspan of a beam, but for sake of just keeping this aligned, I'll dead end that support there, and then we'll go down to this next line, and here we'll go up to this support right there. So here I have not added any splitters at all. I just added my support lines. If I was to just generate, and I recommend that you do this when you're working on slabs, just to kind of see what areas need refinement and need splitters. If I go to strips and I generate my strips for this direction, it's adding middle strips. Let me close that. I'm not going to assume this is an RC slab. I want to assume it's PT. So let's go back to the PT mode. I could have selected no, by the way, in criteria, but I just want to get this in the right mode. And I'll just regenerate. The program will essentially erase what it's done and redo. Now, if I look at this in the report plans view, you can see that it actually looks okay. I mean, clearly there's tributary extending into openings, but we never added splitters to openings to begin with. You can see, for example, this support line is bound on both sides by the slab, so this is the correct tributary. This tributary stops, the support line stops here, so that the tributary can only extend as far as the support line. So it actually extends up to here. And then there's this piece of this area out here to the left that has tributary. This is a mistake. It's just wrong output by the program because we don't have a splitter or splitters plural in this region. So we'll deal with that in a moment. This looks okay. This one looks okay. Again, we get this weird piece here. This one actually stops at the right location. So everything here looks decent. Really, the only mistake, let's say, that would be negatively of negative consequence in actually designing these strips would be this support line right here. This support line starts right there. I'll use this pen. It starts there, which is where the tributary starts, and it ends there. This blue region is the tributary, but you can see that this brown region kind of creeps into this zone. So this point is inside of the slab, and there's no splitter. If I put a splitter here, then what would happen is the tributary would come out like so. It would come down, and it would do something like this. This tributary for this support line would go from there, let's say down to here, so it's this zone, and then this support line 67 would be kind of around that area. So we need to add a splitter at any location where a support line terminates inside of a slab. Okay, looks like there's another question. Let me go and let me turn off the highlighter. That helps. Okay, so there's a question here. The question is, should I extend support lines past the ends of parallel walls to account for negative moment past the support? So yes, the question really is, let me discard this. These walls right here, there's, if I was to take a design cut at some distance away from the edge of that wall, you're going to have negative bending, and it's going to essentially dissipate and have some point of where it goes to positive in this bay. So the question is, should we extend this support line out a little bit to pick up the effects of that negative bending? I would say yes. I didn't do it in this example, but it's a good point. If you want the program to pick up those effects and to extend the reinforcement requirements into that zone, then yes, you would want to extend that out into this area. And usually you might go half the bay length. So for this, I mean, you might go all the way out here. That might be a little extreme, but it's a good point. Okay, just as a quick reminder, it's 2:57. I'm going to go about 10 minutes over today, so those of you who are interested can stay. I will record it. The recording will be distributed, but I want to get through at least showing the splitter input for this slab. So if you need to leave, obviously feel free to exit the meeting based on your schedule. We're now going to go and add splitters for this slab to refine our input. So the first rule of thumb, as I mentioned, we want to have splitters really at support lines that terminate inside of the slab region. This is a good example, this support line here. Notice, by the way, that support line aligns with and it's kind of stacked on top of the opening. That's not ideal, but we'll manage to work with that. So I'll go and add a splitter. I know it's an X direction splitter without even looking at the assignment and the properties because it's a circle, so that's good. And I'm going to add a splitter from this point. And let me turn off the snap midpoint. I will extend the splitter vertically to the next support line above, which is continuous, or a slab edge, whichever comes first. So there's a support line there. I'll stop it. I'll press C to close, and I'll go back to that point and extend one vertically downward, and I'll do the same thing here. But here, this point is also inside of the slab, so I need to take that and chain it vertically to the continuous support line above, and I'll do the same thing below. And now we have an enclosed region, so the program can now look at this, and here we have a support line and a support line, and we have a boundary, and here we have a boundary. So it can take half of this, distribute half of it to this support line, and this half goes to the support line below, and it's closed off by boundaries, which are the splitters. Now below this slab, we have again a boundary, I should say below the support line, and we have another support line. So it can now break this zone into half and bound the tributaries by those splitters. And again, half of it goes to this support line right here. The other half goes to the support line down below. And that's how the program is essentially interpreting those support lines and those splitters. We'll go through, I think that's the only instance where you actually have one inside of the slab. Now, out here, this is kind of a special condition. This model has some unique characteristics to it in terms of how we want to do splitters and support lines. Because we want to bound off this zone and not have those strange tributaries created that overlap into this zone, we want to have those kind of self-contained, if you will. I'm going to add a splitter along this boundary. So I'm kind of forcing and I'm imposing the program to stop the tributary along this boundary because we clearly saw that it leaked into this area. Now I'm going a step further and adding a splitter along that zone. So I'm going to take a splitter and just go all the way to the top corner of the slab, and I'll snap down to this line, this line. There's a corner of a support line which kind of stops at the corner of the slab, and we'll take this all the way down to there. So now in this zone right here, we get the same type of output. We have a support line. We have a boundary, which is now a slab edge, not a splitter, but it's still acceptable. Obviously, it's a slab. And then we have a splitter. So half of it goes here, the other half goes there. Now we have kind of a quirky little thing going on above. We have no splitter, but we have slab. So if I do not add a splitter, the program is going to extend tributary up into this region. But I want to bound it off. I want to, again, self-contain this area. So what I'll do is I'm going to add a splitter, which notice, by the way, I haven't changed directions on the splitters. I'm orienting them all over the place, and they're always X direction splitters. So I'm going to just take a splitter from here, and I'll use my snap orthogonal, and I'll just extend that out like so. What will happen now is this tributary for this support line is going to stop and bound off at that line. It's not going to extend out into this region. We'll do the same thing on this side. It's a similar type of condition. So let's go from here. We'll just extend it down to the edge of the slab. I'm creating a boundary for these tributaries to stop at that boundary, but then I have this support line which continues through, and it's going to extend out into this zone unless I put a boundary again. So I'll take this and add another boundary, let's say there, over to here. Okay, now I'll go ahead and generate my strips again, just to check and see what I have now. Now I have these completely bounded off from the rest of the slab. If I look at my tributaries in this direction, now that we're refining this kind of step by step, so I have nice tributaries. Here's that half of that tributary that we cut off with that splitter vertically here, and down in this area, I was highlighting this before, but now we have, proper tributaries for there's a tiny little tributary for support line 62, but it's still valid because we want to kind of isolate that region to design, that portion of slab. We want some rebar along that wall. In order to get rebar, we have to have a tributary. We have to have design cuts along that path. So this becomes our set of support lines and splitters. Now we have situations where the support lines extend into walls. or I'm sorry, extend into openings. So here this extends into an opening. Remember, this is actually okay. Visually, it may make the user nervous to have this. So we want to ensure that no opening it has design cuts extending into it, even though in the background it's the same thing as if you did have in this case. So we'll go to strips, discard, and I'm going to add splitters around openings to bound them off. If an opening has splitters on all four sides and there's no support line in the opening becomes essentially a void or an island in a tributary region. So I'll give you an example. We have this opening. I'll go and add my splitters. You're going to see me select the corners of openings often. The only reason I do that is because it's easily snappable too. So if I go near that, it snaps, and I can align splitters using that almost as a control point. So I'll just go from there. I'll go up to this line. Again, I'm snapping perpendicular because it's easy to snap to. It's not because it means anything. I could have easily just turned this on to snap orthogonal and just aligned it like that also, but it has to close off at a support line. And then here I'll go from here down. Notice that if I have snap orthogonal turned on, it's hard to tell where to snap to, so I want to turn that off. And I'll go from that point down to my support line. So my support line here, again, coincides with the opening edge. That is not ideal, but what I can do, if I have that happen, what I normally do is I'll pull the splitter off of the edge just slightly. This is just completely arbitrary, but you can see now I can see the splitter and the support line both. This section a design cut is going to extend slightly up into that zone, but again, there's just opening there, so it's not a big problem. It's just a way for me to isolate the two and be able to see both of them. There's a question. Do you have to bound the opening with both X direction and Y direction splitters? The answer to that is yes, Adam, you do, but it's with respect to either support line direction. So everything that I'm doing at this moment is really only used to generate the X direction tributaries. When I go and I switch this to Y direction, you have a completely separate set of splitters to bound off the opening. So these splitters that you see are in no way used for Y direction. It's almost like you're starting over. You have two sets of input for both strip directions. Hopefully that answers the question. Excuse me. This particular set of splitters, now we have an opening here. You can't really see the opening, but there's the opening. Now I have a splitter, 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 and splitter, but there's no support line in the opening. So that means that this will become void. You're going to have a cutout in your tributary regions. And let's go ahead and generate. So if I go to strips, generate, regenerate, now we have this cutout. And if I turn on my tributary regions, you can see what that looks like. On one side, this comes down, it cuts down and around the opening. On the other side, it cuts out of the tributary. So this now is what the strip looks like. And these sections literally just come to the face, or they actually are extended to the splitter, not the face of the opening. Here, this extends to the splitter, but the opening really is along this support line. So this is my input for splitters around that one opening. Now I'll go ahead and do a few more here just for the sake of being able to see how these would be input. So I'm still creating X direction splitters. I'll keep emphasizing snap tools are very important. Now I'm going to input these a specific way, and then I'm going to show you that these are essentially useless if we don't close them off. So here I have splitters, but there's no splitter that closes off the top and bottom of the opening. So the program sees this, and it doesn't really care that these are actually here, because it's going to create a section that does this. It will create a section that does that. There's no splitter here to say close that off on the top or the bottom. And these are basically useless in this scenario. So if I generate my strips again, you can see these all extend still into the opening. There's no difference. So we have to have the splitter legs that close off the top and the bottom. Again, the top and the bottom are aligned with the support line, so I will pull them off just ever so slightly. Let's go there, and I'm not going to perfectly align these just for the sake of time, but you can see now we have a situation where, again, the opening is kind of bound by 4 splitters on either side, and the splitters are extremely sensitive to snap tools. For example, if I miss the snap point just by a hair, there's a gap there, you'll see that this will leak tributary back up into that opening. So we'll go back, regenerate. These are all void. 1, 2, 3. This leaks into the top face where I have a splitter because of that gap in that splitter arrangement. So if you have too many snap tools turned on, that can happen to you. And if I close that off, I'll get proper generation there. There's another question. Yeah, X or Y splitters should work completely independent. Yes, they work independent in and of themselves, but they work in conjunction with the the input of support lines. If you just went in and drew arbitrarily a bunch of splitters, and then you drew, let's say you assign them X direction, and then you drew some support lines in the X direction, the program would interpret those X direction splitters when it's generating tributaries for your X direction support lines. But it would have, the X direction splitters would have absolutely nothing to do with the generation of the Y direction support lines. They are used in conjunction with the support line, but the directionality of it is what makes them independent. Okay, one last thing that I'll demonstrate quickly. In this case, by the way, let's go and look at that input or output. Now you can see that the openings are now bound off. They're cut around in this output here. We have more openings around other areas of the slab, but the same types of input of support lines would be used to create those voids. We now want to add, let's say, support lines to these beams. These beams need to be designed. There's a slab that's kind of sliced around here, so I have to have support lines to design, let's say, those beams with their flanges. And so the first thing I need is support lines. I don't have any support lines along the beams. I'll go ahead and create a support line. This is still X direction. So even though this is kind of aligned almost vertically, it's closer to vertical than it is to horizontal, we're still calling it X direction. And so if I go, I'll create a support line along that path, along there, and along there. The support lines touch the edge of a slab on the top, so I don't need any splitters there. But here I'm going to add splitters at the face of this opening. So I'll go ahead and add a splitter again from here, and I'll just make it perpendicular to this splitter there, and I'll chain these 3 together like so. I could have gone to that point. I'm just snapping perpendicular because it's easy. We'll go now and generate our strips again. Okay, now I have this splitter here bounds this beam that's oriented in the X direction from the tributary for this beam. And I have, again, tributaries for each of those beam lines for in these other slab regions. For the perimeter beam on the outside and this ring beam on the inside, those would be assigned as part of the Y direction group. So we're not assigning them as X direction, we're assigning these as X, those will be assigned as Y, and the same thing would happen down below. There's one more question. Yeah, as a rule of thumb, I'll read the question. As a rule of thumb, all openings should be bound by splitters in both X and Y directions. Is that a correct conclusion? It's only required, as a rule of thumb, yes. Just to keep the model as clean as possible, I would bound the openings with splitters. So for the X and the Y directions, they're completely independent. For X direction support lines, you need X direction splitters. For Y direction support lines, you have to include another set of splitters that are associated with the Y direction. So what we're doing now, in other words, I cannot reuse these splitters for my Y direction. I have to re-input splitters for my Y direction strips. Everything I'm doing now is all X direction. I have to do the same thing for Y direction. So that's a distinction in that case. Okay, the last thing I'll make mention of, I'm sorry for going so long today, but I feel these are important topics. Every support line in your model is categorized as a design type. So for example, if I double click on this support line, if I go to design, the criteria for this particular support line is a two-way slab. That means that when the program is calculating minimum reinforcement requirements or stress checks for this particular support line, it's using the criteria set up for two-way slab. And if you go to criteria, you can see there's two-way, one-way, and beam. The program has different inputs for these three criteria, different preferred bar sizes, different allowable stress settings, and so on. So you have to be careful of what the design criteria is. For these beams, for example, here, these are set to two-way slab. So I would probably change those to beams. They are not two-way slabs, they're beams. I would make that change. If you have a support line that includes both, for example, I have a support line here that is basically two-way slab, and then at the far right end it has a beam. So it's what I would call a hybrid support line. If I wanted to avoid having to break this support line into one, let me use the highlighter again. So let's say 1, 2, and then actually just 2. So this is a beam. This is a two-way slab here. Without having to break this into two support lines, the program is smart enough to recognize that there is a beam on a two-way slab support line. And by default, it knows to categorize, or let's say design the beam respective of the building code requirements for beams. Under criteria, analysis, and design options, there's this option that says design all beams using the respective building code requirements for beams. So this is a kind of a safety net for that situation where you have a hybrid support line. Another thing I'll mention, whenever you have beams in a model, I would always use this option, include waffle/joist construction. This is just a safeguard. It means that if a design cut cuts through a beam, again, here is a beam. If I double click, that's a beam. If a design cut cuts over the beam, then the beam is part of the design section. That means that the program, the physical cut looks something like this. And the program uses that beam stem as part of the design section. So when it calculates the effective depth, it's based on the stem. When it designs reinforcement, it's based on this, the mechanical properties of this section versus a section that only has a slab, just a rectangular, let's say, flat slab, like so. So always use waffle joist construction whenever you have beams. If you don't use it and your support line does not snap on the end point of a beam, you're going to end up with the program using this section without potentially knowing that it's using that section. So as a safeguard, always use waffle when you have beams in a slab. There's a question. Yeah, Pavel mentions he's never had such an issue. Program does recognize beams. Having seen thousands of models, I can say that it can be an issue. You know, that's great that you've never seen it as an issue, but we've seen multiple times when a user will send in a model and the stresses are very, very high, and this is the reason why you have that type of a condition. So again, I would use waffle. I mean, it's an easy thing to do. Go in, select waffle, and you're done. So we'll conclude there today. I appreciate everyone's attendance. I will send everyone the video and also one PDH hour certificate for that. I'll stay online for the next five minutes or so for any additional questions. If any of you have questions, I'll just monitor the question, and for those that need to run, again, I appreciate your attending today. Yeah, is there documentation related to support lines and splitters? Is there any updated reference manual for Adapt Builder? The Adapt Builder, let's say we call it the quote-unquote Getting Started Guide. It was updated and released in conjunction with the updated Floor Pro manual, which has information on support lines and splitters. I'm not going to say it's extensive information, but we also have videos online on our YouTube channel which supplement all of our documentation, videos which show similar topics that we've discussed today. So there is updated documentation for Builder 2016 related to the program in general. Floor Pro does include support lines and splitters. Can splitter definition around openings be automated? The answer to that is programmatically yes, but we are going to, in the future, in the current version of the program, you cannot automate splitters around openings. You have to input as I've done. I'll answer the question more from a development standpoint. In the future, we're going to eliminate the need for splitters altogether. So our goal is to be able to very easily create strips with better internal program logic and algorithms where it would essentially result in us not even having to use splitters. That's the direction we'll take it when we move forward in development on strips and support lines. Next question, for waffle joist construction turned on, do you need to do that under beam criteria or 2A slab criteria? That's a good question. It actually applies globally to all criteria settings. So some of these inputs in the criteria menu are global to all three criteria. If you, for example, go to analysis and design options, this is global for all three. If you go to allowable stress, for example, this changes, the inputs change based on the criteria. The same thing is said for preferred reinforcement size, the inputs change in this window. So that waffle setting really applies to all three. Let me go back to questions. Looks like I lost the... There was another question. If you don't mind, please ask the question again. I cannot, for some reason, I'm unable to open the question box on my panel. So if whoever had that last question, please enter that one more time if you don't mind. If not, then I'll just wait again a couple more minutes here, and then we'll conclude. Yeah, the question or the comment is from Pavel. It's always a good idea to actually put a line parallel and adjacent to a wall in order to get the program to report the stresses and also to avoid coarse distribution in slabs. What Pavel means by that is the following. If you have, let me go back to an example I had earlier, had set up. If I have, again, my slab here, and then I have a wall like so, and I have a couple of support lines again in between. And imagine these bays are fairly long. Let's say this is 30 feet or so, and then I go ahead and generate support lines along here, and along there, and along here. The tributary for this wall strip will look something like this. So even when you put a support line along a wall, you're still going to be integrating over this bottom edge of the wall, let's say 15 feet, which is still pretty far. So what the recommendation is that Pavel was mentioning was, if you want to calculate the stresses right near the wall and the reinforcement, you can always add additional support lines at the sides of walls. And so what we could do is we could add another support line right along the face of the wall, like so, and that means now that the tributary will actually be something like this. So now the tributary is like this, and I'll break that. But the design cut now here does not extend over the wall, therefore we actually get stresses calculated up to the location of the wall versus no stress being shown. Remember, a design cut that extends over a wall, there are no stresses that are reported along support lines. So if we want to obtain those results, we break it further into more support lines to get more results. Okay, and the next question was, where slab is supported by walls, does the support line need to be one way? Yeah, let me go back. So here's a continuous support line. This slab, obviously, in this direction, I would still consider this two-way, because in the bending is really two-way bending out in the field. Ultimately, you're just not going to get any bending over the support line if we refine the input of support lines like was just shown. In the other direction, however, the question is, would support lines in the other direction be one way? And we'll go to general Y direction. So we have something like this. And the answer is still, I would still keep this as two-way. Unless this was truly behaving one way, this is, again, a hybrid. It's going to start behaving more one way when you get closer and closer to the wall, but out in the field here, it's really two-way action. So I would still designate this as two-way. Ultimately, we're trying to get both strength reinforcement and minimum rebar in the design. The program doesn't care whether it's one-way or two-way when it comes to strength reinforcing. When it comes to minimum reinforcing, then it's going to use different, let's say, different criteria. For example, one way we apply for a post-tension slab 0.004 times the area in tension for one way versus different requirements for two-way. So you could potentially make the argument that, well, it's behaving more one way in this span here, therefore I want the program to calculate the minimum rebar based on one-way action. If you go to that extent in dissecting the design, then you could basically run the model with one-way strips to get the rebar in this end bay, and go back, change them to two-way to get the rebar in the middle portion of the slab, or you would discontinue the support line, let's say at the mid panel, and then create a one-way strip. So I'll do that. You might have something that looks like this. I'll stop it and then I'll pick it up again. Stop it, pick it up again. This could be designated as, let's say, one-way, and this designated as two-way, and then one-way again. Again, this could potentially, this would result in incorrect lengths of reinforcement over this column because the span length is defined from there to there. So that would be the negative outcome of this type of an input, but you would still get the right areas of still related to the design types for those strips. And if you have this configuration, you actually would have to have splitters also that went from here, and they would kind of link between the regions, because remember, this support line stops and starts at that point inside of the slab. Okay, so Michael, I got that question. I'm just going now through the list of questions. Pavel's question was answered. Will slope slabs be in the future for ramps? The answer is yes. How soon? I'm not sure. I don't want to give you a time frame on it, but the real problem with slope slabs is being able to support post-tensioning in the ramp. That's the gist of the programming technicality, and some of the I wouldn't say it's a problem, it's just a challenge to make the tendons work in that type of an environment. So when we do release the ability to do ramp slabs, it would only be available in the RC module versus PT, because we have to work out from an architectural standpoint, program architecture, how we can use tendons that reference a slab which is being sloped, and it has to do with how the tendons are being offset to a reference plane or an analytical plane, and some nuances in that respect. So the ramping of slabs is something that is on our roadmap. I cannot say it would be in version 2017. I would say it's more likely to be in the 2018 version. But there are a few ways to address ramping type conditions and just overall, let's say, global models that include ramps in the program. I realize it's not ideal or it's not perfect, but there's a few options, Ken, that we can discuss outside of the meeting. So does the program calculate flange width automatically for T or L beams when a support line is assigned as a two-way slab. I'll just answer this in more general terms. The program doesn't calculate effective flange width at all in the program. The notion of effective flange width technically does not apply to finite elements in the way that the stresses are calculated. However, if the user wants to apply effective flange to beams inside of the program, you have to use splitters currently to bound off the flange widths inside of a strip, for example. So if we had a beam, let's say from this column to this column, and we have support lines that go from here to there. Let's see, right there. And we have a support line that does something like that. Again, sloppy input, but this is just for demonstration purposes. So in this case, the tributary would really run, from midpoint to midpoint of the two adjacent panels. The effective flange might be something like this. In order to do that, the user would have to input splitters. So you would have splitters that might go from there up to there, from there up to there, and then I would put a splitter, along there and a splitter along there. And that you have to use this splitter input to bound off the flange for beams. Now, with that said, one of the projects we are working on for version 2017 is the ability for the program to handle, let's say, beam design in a more modular approach. So right now, when you have beams in a slab and builder, they're kind of intermingled with the slab, and they're not really set aside as this beam. It might be 2-span, 3-span, a single beam is its own entity inside of a more global two-way slab. What we're working on is a beam section manager. So the program would be able to identify beams. So any beam that is linked together becomes a continuous beam, or becomes a single beam in this case, and that beam has a section assigned to it. So this section, I can call it section A, for example. The section has a flange width, it has a stem width, it has reinforcement that you assign to it as base reinforcement, and the program allows the user to use this modularized approach to beam design and detailing as a kind of a standalone wizard built inside of the program, and it's going to allow you to handle the beam design more cleanly versus how we do it now. That is a project we're working on for version 2017, and it will be similar to our column design module, where you can kind of compartmentalize the component design rather than have it combined with the entire slab as a whole. Okay, I think that's all of the questions in the queue now, so we'll go ahead and conclude. Again, thank you for joining today, and look for upcoming emails about other webinars. We're going to have 2 webinars per month. Those are open to all active support clients, and we're looking forward to conducting and holding those. So thanks again. Have a good day.